Okay, so for today, we're going to talk about a new function called the log function. But before we do that, let's start off with this question. So I want to know how long will it take to have a total of $600 if I invest $100 at a rate of 30% compounded yearly. So in the last section, I think we went over two different equations. We have either the PERT one or the non-PERT one. So for this case, since we're compounding only yearly and not continuously, we're going to use the non-PERT one. So we're going to use the P equals P naught times 1 plus R over N to the NT. So let's see. I know my R is going to be 0.3, so this gives me R is 0.3. And since we're compounding yearly, that means N is equal to 1. And then I want to invest 600, or I want to have a total of 600, so this should be my P. And lastly, this should be my P naught, because that's what we're starting off with. So then, what are we solving for in this case? Well, since we're asking the question of how long it will take, basically we're going to solve for t. So let's just do some algebra. So I'm going to simplify what's inside the parentheses. So really this is 600 is equal to 100 times 1.3 to the t. Divide by 100 on both sides. So we get 6 is equal to 1.3 to the t. Okay. Oh, but hey, how do we solve for an exponent? I mean, I guess I can just plug in numbers, but that would take forever, right? I mean, I want to know, I need to solve for the exponent. So does that mean we can divide by 1.3? Well, let's see, what happens when we divide by 1.3? Well, that doesn't make sense because it's not like we're multiplying t by 1.3. So that doesn't work. So can we take the root of t? Okay, sure, yeah, we get 1.3 here, and then we get t root of 6. But now we're looking for the root of t. So that's not going to work. So what are we going to do? Okay, so basically we need an inverse function for exponents. And that's what we call the log function. Log is short for logarithmic. I can't even pronounce it. It's short for logarithmic. Okay. And the thing is, to use the log function, this is the formal definition. If we have a base raised to some unknown number, so x is our unknown, equals y, this is the same thing as saying I'm going to take the log of base b of y, and that'll give me my exponent. So notice, the way I wrote this was I was saying my unknown, well, if I send everything through the log function, it'll give me the output as my unknown. So going back to the question, 6 is equal to 1.3 to the t power. So I'm just going to rewrite this. This is going to be now log. What's the base in this case? The base is 1.3 of 6, and I'll equal my unknown, which is the exponent. My unknown is always the output of my log function. Okay, so now you're thinking, okay, what the heck is this? Well, here's the thing. Log is a function. So back in the day, before people had calculators that had log functions in them, they used to have tables like if you want to know a number and you take the log of it, it'll give you the number. So back in the day, if they want to know what the log of 6 was, they would go to this table and it'll tell you. But since we have a calculator, what we're going to do is take it out, and what I want you to do is look for the log button. Where is log? If you notice, log is above ln, it's on the left side, and what you'll do is you'll put this in your calculator. You'll put log of 6 divided by log of 1.3, and If you hit enter, you'll get the answer of 6.83 equals t. All right, why did you have to use log twice to solve for this? The reason why is your calculator works in base 10, meaning right now, if you put in log of just 6, that's not going to work because it's not log 1.3. What your calculator does is log of 10 and then puts in 6. So whenever we don't have a base that's 10, you have to do this thing. So for instance, another example would be if we took log of base 2 of 10. So for this, since we're now working in base 10, you have to put log of 10 divided by log of 2. And this is actually called a change of base, which we will go into more in the next section. So what I want you to know from this lesson is that whenever we don't know our exponent, what we do is we use the log function. Okay, so for our problem that we were solving for, it was nice because we're asked for an unknown when we're compounding yearly. But let's say we're compounding continuously. So instead, we don't have an n anymore, right? So can we still use this formula? The answer is no, because check this out. I mean, you should know, oh, I need to use the PERT equation now. So if we plug everything into here, well, I still want to end up with 600. I start off with 100. My E is just a constant. My R is 0.3, but now I want to solve for T. So same thing, let's just solve for T. Okay, divide by 100 on both sides. So we have 6 is equal to E to the 0.3 T. Oh, but hey, I have something bad happening. My T is in, I don't know, I'm getting this weird thing. T is still in my exponent. So guess what? We're going to use log again. So let's see. If we rewrite this, it'll be log base. Well, what's my base here? It's E of 6 will give me my exponent. Okay, but once again, our calculator works in base 10, so we can't just plug in log of 6. What we need to plug in is log of 6 divided by log of E, and that equal 0.3t. So on the left-hand side, if you plug that into a calculator, you'll get 1.79, which equals 0.3. And we want to solve for t, so since the right side is being multiplied by 0.3, we're going to divide by 0.3. So we get t is approximately 5.97. This is all good and stuff, but you know what? ln is such a special number that it has its own log function. So the function is called ln. Ln is just an abbreviation for natural log. It's Latin, so we English-speaking people have somehow reversed it, but it's ln for us, okay? So we call it natural log. So whenever our base is e, instead of using regular log, we're going to use natural log. Now notice, I didn't even have to write my base for natural log, because natural log is just assumed to be ln. So to finish off this problem, we get ln of 6 equals 0.3t. But hey, when you plug this into your calculator, what do you get? We also get 1.79. And check this out. Isn't that the same thing that we got over here as well? So this is to prove to you that if you use natural log, it's the same thing as when we do something like this. But natural log, once again, is only for e. Okay? It's not for 10, it's not for 32, it's only for e. So in this case, t will once again be 5.97.